Case study: the video shows a related to an RDBMS engine, highlighting various components like events, workflows, messages, attributes, security, processing logs, and configuration. Let me explain how an RDBMS engine works in terms of inputs and outputs and its integration with an AI engine using Python. Pradeep K. Suri. Author, researcher, and AI/ML architect. RDBMS engine, inputs and outputs. Inputs to RDBMS. 1. Data sources. Structured data from applications, files, or data feeds, example CSV, Excel, JSON. Unstructured data converted into relational formats using ETL tools. 2. User commands. SQL queries, example select, insert, update, delete. Stored procedures and triggers. 3. Events and workflows. Inputs from workflow engines that initiate database operations based on triggers or schedules. 4. Security and configuration. Access control settings, user roles, and authentication tokens. Configuration parameters for database tuning. 5. Logs and notifications. System-generated logs for database operations and notifications from integrated systems. Outputs from RDBMS. 1. Query results. Tabular data returned as the result of SQL queries. Aggregated reports and datasets for analytics. 2. Logs and monitoring data. Performance logs, error logs, and audit trails. 3. Notifications. Alerts or emails triggered by specific database events. 4. Exported data. Data in formats like CSV, Excel, or JSON for downstream processing. 5. Integration points. APIs or middleware connections that allow integration with external systems, including AI engines. Integration with AI engine using Python. 1. Data flow between RDBMS and AI engine. Input to AI. Extract data from the RDBMS using libraries like PyMySQL, Psychopage 2, or SQL Alchemy. Transform and pre-process the data, example feature engineering, cleaning. Output from AI. Store predictions, insights, or model results back into the RDBMS for reporting or further processing. 2 steps for integration. 1. Connect to the RDBMS. Detailed explanation of the Sankey diagram, RDBMS process flow and AI engine integration. Overview. The Sankey diagram visually represents the flow of processes and data within a relational database management system, RDBMS, integrated with an AI engine. The flow between different components and stages is shown, highlighting the complexity and interconnectivity of modern database systems. Each stage is represented by a different color, and the width of the connecting bands indicates the volume or importance of the flow. Key components and their roles. 1. Events. Description represents occurrences within the RDBMS, such as user actions, database triggers, or scheduled tasks. These events are the initial points that generate data or require processing. 2. Workflow. Description defines the sequence of operations or tasks that need to be executed in response to events. Workflows ensure that processes are carried out systematically and efficiently. 3. Messages/notifications. Description involves sending alerts or updates to users or systems based on certain conditions or changes in the database. This ensures that stakeholders are informed about important activities or anomalies. 4. Processing logs. Description records all operations and changes that occur within the RDBMS. Logs are essential for auditing, troubleshooting, and ensuring data integrity. 5. Functions. Description encapsulate reusable code blocks that perform specific tasks or calculations within the database. Functions help in maintaining cleaner and more modular code. 6. Processes. Description denotes ongoing activities or tasks that occur within the RDBMS. This can include data processing, batch jobs, or other operations critical to database performance. 7. Security. Description encompasses all measures and protocols put in place to protect the data within the RDBMS. This includes authentication, authorization, encryption, and monitoring for suspicious activities. 8. Help. Description refers to the resources and documentation available to users for understanding and using the RDBMS effectively. Help resources can include manuals, FAQs, and support forums. 9. Configuration and DB tuning. Description involves setting up the database environment and optimizing its performance. This can include adjusting parameters, indexing, and other performance-enhancing activities. 10. Attributes. Description represents the various data attributes or fields within the database tables. Attributes are the fundamental elements of database records. AI engine integration. Description: the AI engine is integrated across all stages, providing advanced data analysis, predictive modeling, and automated decision-making capabilities. It interacts with each component, enhancing the overall efficiency and effectiveness of the RDBMS. Flow: the AI engine integration is shown as a continuous flow at the bottom, indicating its interaction with various stages of the process. Flow and connectivity. Visual representation: the width of the connecting bands indicates the volume or importance of the data flow between different stages. Thicker bands suggest a higher volume of data or more critical processes. Integration points: the AI engine is shown to interact with multiple stages, highlighting its role in enhancing workflows, processing logs, security, and other functions. Summary: this Sankey diagram effectively illustrates the interconnected processes within an RDBMS and the integration of an AI engine to enhance various functionalities. It provides a clear visualization of how different components interact, emphasizing the importance of each stage and the role of AI in optimizing database operations. Thank you.